Hello and welcome to the module on t-test. By the end of this module, you would have understood what is t-distribution and the t-test, what is it exactly used for, how to use it, what are the different types of t-tests and when exactly to use the t-tests. Before we understand the t-distribution and the t-test, let us first get acquainted with a few important statistical terms and terminologies. To begin with, let us see what is population. Population refers to a complete set of people or events that share a common characteristic. Sample, on the other hand, is a subset or a subgroup selected from this population with the intention of studying it. The sample mean, usually denoted by x bar, is an unbiased and a consistent estimator of the population mean, which is again usually denoted by the Greek letter mu. It is also important to remember that an estimate is just an approximate calculation and not the actual value. The population variance is obtained by measuring all the members of a given population and then entering all these values into the formula given by sigma square is equal to summation the difference between the values and the population mean, that is x minus mu bracket square divided by the total number of units in the population, that is capital N. So, in the above formula, x denotes the individual value of a member of the population, mu denotes the population mean and N denotes the population size. An unbiased and a consistent estimator of sigma square is provided by the formula S square, that is the sample variance given by summation xi minus x bar bracket square divided by small n minus 1. Remember, here small n denotes the sample size. Also note that the denominator here is n minus 1 and not n itself. The sample variance is given by S square equal to summation capital Xi minus x bar bracket square upon n. But this sample variance comes out to be a biased estimator of sigma square, as it underestimates the value of sigma square. So, instead of using small n in the denominator, we prefer to use small n minus 1 as given in the previous formula. The sampling error is the amount by which a particular sample mean differs from the population mean. For a population with a standard deviation sigma, the standard deviation of the sampling distribution will be sigma x equal to sigma divided by square root of the sample size, that is small n. Instead of calling this as the standard deviation, we usually prefer calling this as the standard error of the mean or just the standard error, and is usually represented by sigma suffix small x. The sampling distribution of the mean provides a method of assessing the variability expected among the sample means. But the population standard deviation sigma is a population parameter, and any population parameter, as we all know, is generally not known. The problem then arises is how to determine the standard error sigma x if sigma itself is not known. The solution to this lies in estimating sigma from the sample data. So, we have estimated sigma x, which is denoted by small x as S upon square root of sample size, that is small n, where small s is obtained from the actual values in your sample, n denotes the sample size. In some articles, the standard error is also often identified as SE. Different random samples from the same population will produce different standard deviations, because of the chance factor in the scores that occur from one sample to the other. The sample values provide the only basis for estimating sigma x. The standard error is used to measure the amount of sampling error in the sampling distribution of the mean. Therefore, Sx may be used to determine how well an obtained sample mean estimates your population mean. The smaller the value of Sx, one can be very well confident that your sample mean x bar does not differ substantially from your population mean. Now, let us come to the t-test. The t-test was developed by a statistician W.S. Gossett, who worked in a brewery in Dublin, Ireland. His pen name was Student, and hence the term Student's t-test, which was published in the scientific journal Biometrica in 1908. The t-test is a statistical tool used to infer differences between small samples based on the mean and the standard deviation. Student's t-test is thus a method of testing the hypothesis about the mean of a small sample drawn from a normally distributed population when the population standard deviation is not known. Let us see what are the properties of t-distribution. The t-distribution is a theoretical probability distribution. It is symmetrical, bell-shaped and similar to the standard normal curve. However, there is a slight difference between the standard normal and the t-shape. It has an additional parameter called as a degrees of freedom, which changes its shape. The spread of t-distribution is more than that of the standard normal distribution. Let us understand what is the concept of degrees of freedom. When you compute a mean using a sample, all but one of the instances is free to vary. So, the degrees of freedom is nothing but the number of instances which are free to change or vary. It is usually denoted by df, and if n is your sample size, df is nothing but n minus 1. The effect of the degrees of freedom on the t-distribution is illustrated in the adjacent figure with respect to the 3 t-distributions as shown. Note that the smaller the degrees of freedom, the flatter is the shape of the distribution, resulting in a greater area towards the tails of the distribution. Suppose we have a simple random sample of size small n drawn from a normal population with mean mu and standard deviation sigma. As usual, let x bar denote the sample mean and small s denote the sample standard deviation. Then the variable t is given as t equal to x bar minus mu divided by small s upon square root of sample size small n. Here s square is nothing but summation x minus x bar bracket square divided by n minus 1. This variable t has a t distribution with n minus 1 degrees of freedom. What are the main assumptions we need to make underlying any t distribution? The first is the scale of measurement. The data that you collect for the dependent variable should be based on an instrument or a scale which is either continuous or ordinal. Second, random sampling. The sample of subjects should be randomly sampled from the population of interest. Third, normality. The data comes from a distribution that has one of those nice bell-shaped curves known as the normal distribution. Fourth, regarding the sample size. Remember, t-test is a robust test. Departure from normality is most serious when sample sizes are small. As the sample size increases, the sampling distribution of the mean approaches the normal distribution regardless of the shape of the original population. Last is the homogeneity of the variance. We assume the equality of variance, and it is actually more important than the assumption of normality. Students T allows the use of a small number of measurements to estimate what may be true of the whole population. This forms the basis of the modern inferential statistics, where a small number of observations are made and the results are generalized to a wider population. Let us now see the applications of t distribution. There are three major types of t-tests which are used. First is the one sample t-test. This is used to test the significance of the mean of a random sample, but pertaining only to one population. Second, t-test for two independent groups. Here, the statistical hypothesis testing is done to understand the difference between two means for two separate independent groups. The third is the difference test. This is used in case of paired data. Let us see one by one all the three tests. To begin with, one sample t-test. Here, we check whether the mean of a sample drawn from a normal population deviates significantly from the hypothetical value of the population mean. To do that, we need to calculate the statistic as told before, that is t equal to x bar minus mu upon Sx, where x bar is the sample mean, mu is the hypothesized population mean, Sx is the estimated standard error of the mean obtained from the estimated population standard deviation, and small n is the sample size. For t-test for two independent groups, where we test the difference between the two means, the samples come from the same normal population. Here, we test the hypothesis whether the samples come from the same normal population. For that, we make use of the statistic t equal to x1 bar minus x2 bar divided by small sx upon under root n1 n2 divided by n1 plus n2. Now, let us see what this all means. x1 bar is the mean of the first sample, x2 bar is the mean of the second sample, n1 is the number of observations in your first sample, n2 is the number of observations in the second sample, and as you all know, small sx is the combined standard deviation. The third, or the difference test, it is also known as the paired t-test. In case of paired data, where we have the same individuals and are trying to find out the effect of them in case of the pre and post intervention, we used the paired t-test. The statistic which needs to be used here is given by t equal to d bar upon sd divided by square root of n. Here, d bar is the mean of the differences between the pre and the post intervention values, whereas s is the standard deviation of these differences. The value of s needs to be calculated as given in the formula below. S is equal to square root of summation di minus d bar bracket square divided by n minus 1. It can be also reduced further or simplified further as s equal to square root of summation di square minus n into d bar the whole square divided by n minus 1. The steps involved to solve the t distribution or to use the t-tests can be very well summarized as below. Step 1, formulate a statistical hypothesis. Step 2, obtain the sampling distribution of your t statistic. Third, select a significance level usually denoted by alpha. Fourth, use the table for the critical value of t. Fifth, make a decision based on your calculated t and the cutoff or the critical value obtained from the table. Sixth, conclude whether to reject or accept the null hypothesis based on your decision. Now, let us see when to use the t distribution. We have to use the t distribution when first the population standard deviation or sigma is not known, and the most important second condition is the sample size has to be small, that is n has to be less than 30. Secondly, if sigma is not known, then using t distribution is correct. However, if sigma is known, then using the normal distribution is more appropriate. Since usually the normal distribution is preferred and t distribution becomes equivalent to the normal distribution when the number of cases are large, the common practice is, if sigma is known, then use normal distribution. If sigma is not known and if your n is large, that is the sample size is large, use the normal distribution, and if n is small, then use the t distribution. Let us summarize the entire module. The t-test is a statistical tool used to infer differences between small samples based on the mean and the standard deviation. Student's t-test is thus a method of testing the hypothesis about the mean of a small sample drawn from a normally distributed population when the population standard deviation is unknown. The t distribution is a theoretical probability distribution. It is symmetrical, bell-shaped and very much similar to the standard normal curve. However, it differs slightly from the standard normal curve in the sense it has an additional parameter called as the degrees of freedom, which changes its shape. The spread is more than that of the standard normal distribution. If x bar is your sample mean and s is the sample standard deviation, then the t statistic is given by t equal to x bar minus mu upon s by root n. This t has a t distribution with n minus 1 degrees of freedom. There are three major types of t-tests used in practice: the one sample t-test, t-test for two independent groups, and the paired t-test. Remember, use the t distribution when the population standard deviation is not known and when the sample size is small, that is your n is less than 30. Hope this module has given you a fair idea about the t-test and the different types of t-tests to be used. Thank you.